Hello everyone. So in the last video, I showed you this app where we can download any crypto data on three exchanges: Huobi, CoinDCX, and Binance, and utilize the CoinDCX public APIs for this. So just to give you a quick example, if I want to download the data for USDT to Indian rupee from let's say uh, July 1st to 13th of August for 5-minute data time frame, I'll just click on get data. It will download the data for me and show me a download button here. So we'll be building this app from scratch right now with you. Let me show you the agenda. So first, to get there, we'll basically introduce you to the CoinDCX public APIs. What are the quirks around CoinDCX APIs? How you can use them? What languages can you use them with? Then we'll show you how to fetch some sample data, like just for 1 minute time frame for like 1,000 candles, and we'll show you all this data comes in Unix timestamp format or Epoch timestamp. Unix timestamp is basically the it started from 1st of January 1970. So it with every second passes, the Unix timestamp changes. We'll show you, you'll get a better idea, and then we'll show you how so CoinDCX APIs right now, with one single call you can only call up to 1,000 candles of data. So let's say you're fetching 1 minute worth of data from midnight 12 a.m. At max you can only fetch data till 4:40 p.m. for that day, just because 1,000 candles get over. So we need to figure out a way as to how to make multiple API calls to fetch that data for our given time horizon, and then we'll finally build a front end application using Streamlit, which you just saw before. So I'll divide this video into probably 2 or 3 parts, just to keep it short and simple. But yeah, we'll overall cover these all topics. Now, my videos generally are very small, very slow and lengthy in time wise. So if you prefer watching them in speed and some of the concepts already, you can just do 1.5x and watch them. So yeah. All right, so let's get started. Let me quickly create a new virtual environment. Again, a very good practice whenever you're creating new applications. So Conda, create name. What should I coin DCX underscore YouTube? And then I'll install Python 3.8. Mm, okay, so let me activate the environment. Conda activate CoinDCX underscore YouTube. And now the libraries that I would need to do this is first of all, I would need pandas and numpy, which are the standard data analysis library. And then finally, when we are building this front end application, we would need Streamlit. But let's go one by one. All the other libraries that we would need are the standard Python libraries, but as and when we progress, we'll realize if we are missing some libraries and install them. Actually, let's install Jupyter Notebook. Let's do the development first on Jupyter Notebook as well. Jupyter Notebook, and meanwhile, let me install Streamlit as well. Sorry, that didn't work. I think for Streamlit, we'll have to pip install Streamlit. Okay, so Jupyter Notebook is installed. Let me install Streamlit now. All right, so our Streamlit is also installed now. So let's quickly create a folder where we'll be saving all the libraries. So I am going to go to a folder which I created before, and I'm going to cd into, so change directory into that, so your path changes, and I'm going to launch my Jupyter Notebook there with the command Jupyter Notebook. If you're launching it for the first time, it might take a while, but generally it's quick. So this is my path where I want to save the files. I'll just click on new Python 3 and then create a new file. So let's just name is at CoinDCX app. Okay. Now we'll install the the import the library. So import pandas as PD for now because that's what we need. Let's quickly first understand how the CoinDCX APIs are working. Okay. So if I go to API reference. So basically, CoinDCX were kind enough to publish a public endpoint where you don't need any sort of authentication. You can get certain pieces of data which you want without providing it with an API key or a request token or anything. You can just go to that URL and you will have that data. But there are certain quirks to using this API. So the data, the endpoint we'll be interested in is the candles endpoint, which basically contains all the candle information for whatever time interval you provide. So basically there is, for Python they have provided a sample script which says you need to use the request library, and this is the URL that you need to go to get that data. So let's say if we copy this URL and go to that URL, and I don't know if you can see this properly, but let me zoom in a little bit. So this basically gives you data in the JSON format where this one particular entry in those curly brackets is a candle. It has the open, high, low, close for BTC against Tether or USDT for 1 minute time interval, and this is at this particular time. Now we talked about time. Time, it's in Unix timestamp format. So how do you interpret this time? So I'll just take this time, copy this, and go to Epoch converter. Epoch in Unix timestamp converter tool. Just paste this here and then convert this. So it tells me that the time is August 15, 1:37 p.m. in GMT. In my time zone, it's 2:37. I am in London right now. If you're accessing this from India or another country, your time zone will be accordingly different. So you can see the timestamp, the epoch timestamp keeps on changing here. It's not updating right now. Yeah, it's got updated. So it keeps on changing here. If I remove the last three, that's basically the last three zeros are for milliseconds. If I just convert that, that's again, telling me 1:37 p.m. If I run this again, that should give me a new timestamp. Basically, that endpoint gets updated with the latest data immediately. So right now we are at 1:38 p.m. So if I run this again, that should give me a new one, which should be 1:39. 1:39. So why do CoinDCX and other crypto exchanges put this in timestamp, epoch's time format? I think so. Primarily, the reason is that because crypto assets are traded globally, you need one common timestamp to track them across multiple time zones. Otherwise, what will happen is I am checking some data at like 12 p.m. IST, and I am also verifying that data to 12 p.m. EST, Eastern Standard Time Zone, and the data is not matching, and you get confused at that point there. So they just keep this in Unix time zone format, Unix format, and because this is 24-hour thing, it just makes sense. The seconds will just keep on increasing, and as soon as a new minute is hit, they'll generate a new timestamp format for Unix. But this is not very readable, right? Nobody can understand, okay, what time is it right now? There are no there's not a defined way to read this. So we'll figure out how to convert that Unix timestamp into the human readable format which we got, let's say, in this file which we downloaded. Okay, in this datetime column. The original data is coming in this format. We need to convert this data into this format so that we understand it. Okay. Now, the other thing that I want you to know is in this API reference. So what are the parameters that it can accept? So it needs the pair which is required. So this pair is basically BTC USDT. So BTC is the first coin, USDT is the second coin. You need the price of that pair, and B is basically the exchange. Well, I'll tell you where you can find all that documentation in a minute. But yeah, moving on to interval. Interval is basically the frequency. Do you need this data in 1 minute, 5 minute, 15 minute. The possible intervals are mentioned here. Start time is timestamp. It's basically in the Unix timestamp format in milliseconds. End time is again in milliseconds. Limit, basically the default limit is 500, but maximum you can fetch like 1000 candles. So here right now we have got 500 candles, but if I want, let's say, 1000 candles, I'll just go here and limit is equals to 1000, and now I've got 1000 candles. You can't of course count it here, but we'll figure that out once we are capturing this data in Python. So in the candles reference, so basically how to construct this pair. So if I go to the very top, which is in introduction section, you see the pair uniquely identifies the market along with its exchange and is available in the market details API. So if I go to market details API in public endpoint, so market details, and if I capture this point, see there are multiple entries here. So CoinDCX name, whatever is the name, base currency short name, target currency short name, blah blah blah, and then finally you have the pair code here. So what this tells me is H is basically the exchange. How do I know that? And if I go to the introduction section again, you see E code is used to specify the exchange for a given market. Valid values for E code include B for Binance, I for CoinDCX, HB for HitBTC, H for Huobi, BM for BitMEX. So H basically here is Huobi, YFI and Ethereum and YFI are the two coins where we are getting their pair value. So that's how the pairs are constructed. We will basically build that function which parses this API endpoint to figure out, okay, what possible pairs do we have to use that in our front-end application in the last part of the video. But for now, I just wanted to show you how this is working. So if I go to the candles endpoint and let's say I want to give it a start time and end time, how do I do that? So let's say and put in a, so start time is equals to, let's say we give it, let's go to Epoch converter and convert the time at 12:00 a.m. and this is the Epoch timestamp in milliseconds. So I'll just take that and end time is equals to, let's take this as the next day. Okay, so actually let's put in 14 and 15. Okay, let me just delete the space, and if I get that data, basically this is the data that I have. But again, you can't count the data and you can't figure out if you have got everything that you need, and most probably you don't have everything you need because the limit for the API is only 1000 calls, and between in one day how many minutes are there? Let's just quickly calculate. So if I open up my calculator, how many minutes are there? So you have 24 hours into 60 minutes. 24 hours into 60 minutes. So you have 1440 minutes in a particular day, but your limit is only 1000 minutes. So you are missing this 440 minutes of data when you are making this call, right? So let's now do this over Python and figure out how we can do this. So we're moving on to the second piece of agenda. So let's just follow the API documentation that they have given. Copy this URL, paste it here, and then copy this thing. So response request.get URL, go to that URL, get the response, and then convert that response into JSON format, which it already is. It's just converting it into a Python acceptable format. So if I open that, you see all of that in a list-based format. Now, if I want to convert this data into a data frame format using pandas, what I'll do is pd.data frame, and then just give it this data, and let's just name this data frame as candles. Okay, and if I look at candles right now, it is 500 rows and it is all the data that we need: open, high, low, close, and the time. Now if I enter limit is equals to 1000 and get that data again, now you see we have 1000 rows of data. Now let's try and go to that particular URL which we were going to. Yeah, this one. I'll just copy this link address again. Okay, so ideally this is the 14th of August till 15th of August 12 a.m. So ideally we should have 1440 candles given the minutes we have, and we are having the 1 minute time interval. If I go to that again, but I only have 1000 rows of data. So we are missing that 440 minutes, and it is very difficult to guess that because this time stamp is not in the standard format, right? It's not human readable. So let's just take a minute and convert that timestamp. So let's say you have this timestamp. How do you convert this? So converting, let's say, how do you convert this timestamp? Let me quickly see. So if, and we are only concerned we don't care about the milliseconds, uh, which are the last three zeros. We are only concerned till the second. So let's say time dot local time and convert that. There's a function in the time library. Oh, I need to import time. So if I do time dot local time, it converts it into structured time. So basically 2021 year, month 8, 15th, or is the day 14th hour 47. So that was just basically getting the data, latest data. So 15th of August 1427. So right now it's 2:48 p.m., which is 1447 and 0 seconds. And then what's the weekday? What is the year day? I don't know what this is. So if let's say I want to convert that to a readable format, there's another function called time.strf time. And if I give it the what format do I need? So let's say I want it in day, then month format, then year format, and then I can get the hour, minute, and second. And I need to give it the timestamp object. So let's try and give it this Unix timestamp object here. It needs a tuple or a struct time argument required. So this is a struct time argument. So let's just give it time.local time. Okay, now this is in a much more readable format, right? 15th of August, 14:47 p.m. So let's just create a quick function. So define local time, and it will accept a epoch time or a Unix time, whatever you want to call it, which is this one. Then what it will do is it will return time.strf time. I'll just copy this whole thing again. And it will time dot local time. Now it needs this thing, but I don't want to give it the extra three zeros. Let's quickly see what happens if I give it those extra three zeros. I think so that's not acceptable by local time. So first what I'll do is strip those extra three zeros. So convert this epoch time into a string, then get those first 10 digits itself, and if I, let's say, convert this epoch time into a string, if I convert this into a string, let's see if that works or not. Yeah, it will not work. It needs an integer. So I need to convert this back into an integer again. And let's try if this works or not. So local time, let's give it any random one. Yeah, it's working. So 14th of August 2212, right? So now let's basically assign, like, let's create a new column in our candles data frame. Candles date, sorry, time is equals to candles dot apply. We'll apply a lambda function. So lambda x, then we'll apply this function. So local time, and I need to give this the epoch time, so which is this column time, and then it's present in axis 1. Invalid syntax. So I made a typo, lambda x. Okay, so that's done. So candles, if I look at candles now, I've got that date time object here, which is basically present here as well. So now this is in a much more readable format, right? So we have solved that problem. Now let's basically try and solve the problem where we are not able to fetch data for more than 1000 rows. So we need to think a little innovative here, how we can solve this and not abuse the APIs as well. Like you are trying to, whatever you request, they will only send you 1000 candles, right? So we need to make the correct request to get the data we need, and then just compile all of that data and present it to the user, right? So how do we do that? So let's try converting to epoch date. So for this I'll import the datetime function. So datetime, from datetime import datetime, and let's say datetime 2021 to 1, which is 1st of January 2021. I'll convert this to epoch or Unix timestamp. So this is my Unix timestamp. Just to verify this, let's quickly see it here. And this is 1st of January 12 a.m. So that is working. Let's say this is our start date. So epoch start date is equals to this, and epoch end date is equals to date time, let's say end of January dot timestamp. Okay, so let me quickly see epoch end date as well. Oops. Thirty-first of January 12 a.m. Okay. Now if I want to split, so we can only get 1000 minute in one go, right? Because the limit is 1000. How many minutes are there between epoch end date and epoch start date? So if I subtract them, so epoch end date, give me a second. Oops. Epoch end date minus epoch underscore start date, you have got these many seconds. Okay, these are seconds because the epoch start and end dates are in seconds. Now let's say if I want to figure out how many minutes are there, so I will go, sorry, divide by 60 because each minute will have 60 seconds. So there are 43,200 minutes. Okay, now if I want to make calls of the APIs, I will have to, I'm limited to 1000 calls per API. So how many calls will I have to make into 1000, right? Oops, not like this. Basically, so I'll have to make 43.2 API calls. I cannot make fractional API calls. So basically I'll just say math.ceil. That's basically go to the ceiling. Not literally, but you go to the upper number, round it off to the nearest integer. Math.ceil, okay, typo. So you make 44 API calls with the correct timestamp format. So basically here you present the start time as the first epoch start time, which is this one, and then plus 1000 will be the timestamp here, Unix timestamp. Then in the next call you take that timestamp as the start and then plus 1000 until you reach the end, which is the epoch end date, and you get like around 44 URLs to scrape, and you, whatever output you get from those URLs, just combine them into one data frame. Okay, so that's basically the approach that we will be taking. Okay, so how do I figure out the plus 1000 minutes epoch timestamp now? So let's say you have epoch start date. There is something called as a time delta function within the datetime module. which I will have to first import actually. So time delta. What do I mean by that is, let's say date time dot now. Okay, so that's the current timestamp plus time delta. Let's say you want to increase it by 20 days. So this will tell you 4th of September is the date now, which makes sense, right? 14. Yeah. If you want to, let's say, do it hours, increase it by 20 hours, then you get the 16th of August at 10:58. So time delta will help us to figure out the timestamp in Unix format every 1000 minutes. So let's take the epoch start date plus time delta, and then minutes is equals to 1000. That will not work, primarily because Unix plus time delta is not allowed, I think. So first I will have to convert it back into date time object. So what's the correct, let's try it. So if I date time dot from time stamp is the correct function if I remember. Yeah. So datetime from timestamp converts it into datetime object, which is required, and then we can add the time delta object. So datetime dot from timestamp, and now you've got that uh, timestamp after 1000 minutes. So remember, I told you at the start, you cannot get more data than, if you're starting at midnight, you will be able to get data till 4:40 p.m. After that, 1000 minutes are over. And now again I need to get the Unix timestamp of this one, so I'll just do timestamp again. Okay, so this gives me the Unix timestamp in the second format, but here the CoinDCX APIs require this timestamp in milliseconds, not in just seconds. So we'll just basically convert this thing into string, string, yeah. And first, actually, first we'll convert it into integers, which will give us this. Then we'll convert it into strings, which will give us that, and then plus 3 zeros. So this will be the epoch timestamp that will be accepted by our CoinDCX APIs. Okay, so let's try and create a loop where we can get these 44 URLs made for us using this particular logic that we have just created. So let's say we have two start date and end date. So we have these start dates and end dates, and now we were able to figure out that we need to loop over this 44 times just to get the relevant URL. So let's just term this as range end. Okay, so this is a range for us. If I look at range end, we need to, so for I in the range 0 to range end, what I want to do is basically, I'm just thinking how to do it in the best way. For I in the range of 0 to range end, so basically URL end date will be uh, start date. So we had an epoch start date. Basically, we need to generate this timestamp that we did, right? So epoch start date, I'll just convert that again. So basically, I'll just copy this, and plus time delta minutes is equals to 1000, because we considering this is 1 minute data, we will create a loop for different time frames, but right now I'm just showing you an example for 1 minute data. And then I need to generate generate the timestamp, the epoch timestamp again. Well, forget about this thing right now. We will directly hardcode that into the URLs that we create. So let's just right now print the URL end date. Okay. In this case, it's all the same, which is not correct. Let me just convert this into integers as well. This is not correct because ideally we should have incremental 1000 minutes epochs timestamp. So what's happening here is we need to convert. So first we went from A to B, which was time delta, this thing. So first we went from epoch start date to epoch end date. Now we want this epoch start date to be updated with this number so that we get the next number. Okay. So what I'll enter is epoch start date is equals to URL end date. So now you have got the incremental URLs, sorry, the epoch URL and end dates. So if we have to, let's say, create all the URLs, so let's say URLs to scrape is equals to, it's an empty list. Okay. If I look at URLs to scrape, it's an empty list. Now I want to generate these URLs. So URLs to scrape dot append, and let's just copy the sample URL which we had here. Copy this. It's an f string. Basically, will f string basically allows you to put variables within uh, this string. So if I look at, so I need those three zeros. What I'll do is put in the epoch start date here, and then 123 the URL end date here, and both of them should be in integers. And this particular thing should be after I have appended that. And now if I run this, let's look at our URLs to scrape. So I've got 44 URLs. I think I should 44. Okay, let's look at the first 5 URLs. So this is from 161. So let's just copy that. This is January 31, 1:20 p.m. But why do we have from 1:20 p.m.? This should start from 12 a.m. Let me just reinitialize this variable, and let me just try this again. Yeah, it starts from 12 a.m. Maybe there was a different variable present in there which is causing the problem. And then ends at 14:40 p.m. hopefully. Yeah, sorry, 4:40 p.m. And if I check this one, so this one and this one should exactly be the same. So 95192, 95192. So let's just double verify. Yeah, it's 4:40 p.m. and this one should now be 1000 minutes later, which is 9:20 a.m. on January 2. So now we have the URLs that we need to scrape. It's just a matter of, scraping the data from these URLs and then merging all those data frames and generating one final data frame. So how will you do that? Let's just say 1 minute data is equals to pd dot data frame. This is an empty data frame. For URLs in URLs to scrape, sorry, uh, basically we will do the same thing, data response to data. So uh, candle data, candle df is equals to pd dot data frame data, and then 1 minute data dot append candle df. Okay, and that should basically work. we are scraping 44 URL, so it might take a minute or two to get there. Okay, so the function has run. Now let's quickly see 1 minute data. Oh, it's empty. Okay, I think so I made a mistake, so I need to define it here again. Let's rerun this. Okay, so that data came through. We have around 440,000 rows of data. Now let's convert that date time. So 1 minute data dot append, dot apply lambda x local time. This is the function we created before. Give it the time object. Axis is equals to 1. And if I look at 1 minute data now, so now I've got data from 14th of August till 15th of August. There's something wrong here. If I sort, how does the sort functionality work? Pandas sort values. So sort values equals to date. You need to by is equals to, so by is equals to date underscore time. There is something wrong here where we are capturing the same data again and again. Let me figure it out. I'll show it to you. I'm quickly pausing the video right now. Sorry about that, guys. I figured out where the problem was. So you see in this URL that we have got, uh, start time is equals to the Unix timestamp, and then end time, and then percentage 20. Now that's not standard for the request that we are making. So if we make that request, which we have got, it's basically not recognizing that you have given an end time, so it would fetch the latest 1,000 candles, which is why we are getting August data. If we get rid of this percentage 20, look at this timestamp 16290 and then press enter. 16095. So now we are getting that old data. So let's just regenerate our URLs to scrape without that percentage 20. I don't know how it got there, but it's fine. At least we know what the problem was. The URLs to scrape empty list. We created a new 1 minute data is new. Let's rerun. It might take a couple of minutes and then just sort the values. Okay, so the program is run and now I still see the 14th of August data. Okay, so we were still getting that 14th of August data, and I have made a very stupid typo which annoyed me. So basically, for URLs and URLs to scrape, I need to scrape URLs. What I was doing was scraping the main URL that we defined, which was for 14th of August till 15, which is why I was getting that data again and again. So we have already generated the URLs to scrape. Let me just reinitiate and create a empty data frame. Let me just run this again and you will see. Should be done any minute now. We'll implement concurrency in the next part. So now you see we have got data from 1st of January till 31st of January 13:20 p.m. But what did we ask for? So we asked for data till epoch end date. If I take this Unix timestamp and convert this, we asked for data till 12 a.m. Why are we getting data till 13:20 p.m.? So there is something wrong which we have done, and probably it's in the URL generation. So what should ideally happen is if the the epoch end date, if the epoch end date is greater, which is the 31st of January 12 a.m. is, if that is greater than the URL end date that we are getting right now, then basically let's say the URL end date is 1st of January 4:40 p.m. and of course this is greater, then we want to run the loop again, right? We want this to stay reinitialize 1000 minutes more, then it will regenerate a URL end date, then it will check that again and then reinitialize for 1000 minutes more. But if uh, else if epoch end date is less than URL end date, then we don't want to do that, right? We just want to uh, generate our URLs to scrape with the end date. So let me just push this here. So we have got a URL end date. If epoch end date is greater than URL end date, then this is our URL. If it's less than, then basically this one should here be epoch end date, so that we stop at 12 a.m. We don't go over and generate one more until 1000 minutes are met, right? This is because the range end that you were seeing. So when we did this particular thing, uh, yeah, we need to reinitialize this and then let's do this. So this is 43.2, so we can't do fractional, right? So we are doing this over 44 runs, but in the last run we should only be taking it till the epoch end date rather than the plus 1000 minutes more, which is why we have to put this condition in. So if I reinitialize this, generate the URLs to scrape again, reinitialize this, generate this again, let's see what we get now. Okay, so now we have got that data until 31st of January 2021 12 a.m., which is what we wanted. This is exactly the data from our start time till the end time. Okay. So this is how we'll generate that data. Now, depending on the time interval, it can be 1 minute, 5 minute. You need to define this thing, the time delta, appropriately. So we'll stop this video here. In the next video, we'll just build that function where we are capturing the URLs to scrape for different time intervals appropriately. And then in the next one, we will build a front-end application. So thank you guys for watching this video. If you like the content, please do hit subscribe button. Thank you.